You see, you are discussing our total differential equations in fourth semester. Here there are four chapters are there. First one is the word ordinary differential equations. Second one is the linear differential equations. Third one is the total differential equations. Fourth one is partial differential equations. Now, my unit is unit number three, total differential equation that I am taking here in case of the fourth semester. Remaining three, one to four will be taken by others. Here only I am taking the total differential equations. Okay. Already we have seen some of the problems based on the total differential equation, and then you have seen the simultaneous differential equations are working method. Okay. Here just to see the working method is what are taking simultaneous equations. Simultaneous equations, the differential equations of the form dx by p dy by q equal to dz by r. That is the standard form of simultaneous equations. Okay. Now here the standard form of the simultaneous equations is dx by p dy by q equal to dz by r. And then here peak to are functions of x, y, z. And I already will discuss the methods. Method of grouping means that some of the terms get absent or that will be cancelled if you take two fractions. Okay, so how the total variables are x, y, z are there. You get three pairs of the different solutions. Three pairs are getting here totally. Out of those three, you have to find out two and how to write the collectively the solution what are getting from those three pairs. We have to write two out of three. We have to find out two and we have to write the solution. That is the case. But the second one is the method of multipliers. Okay. Here we have to choose P1, Q1, R1 in such a way that each fraction is equal to P1 dx Q1 dy plus R1 dy by P1 P plus Q1 Q plus Q R1 R. Here you see the denominator must be equal to 0 so that the remaining will be integrable and you are getting a solution. Similarly, if you take another two fractions and if you find P2, Q2, R2 in the same way, replace here Q1 by P2, Q1 by Q2, R1 by R2, how to get the same denominator must be vanishes. Then only you can apply this. This is the method of multiplier. The first one is the method of grouping. Method of grouping means either one term may be cancelled or it is absent, then you can easily find out the solution. That is the case. How to say you are taking two pairs out of those three and are getting a solution and are writing those two solutions for the solution of the given equation. The method of multipliers you are taking the multipliers P1, Q1, R1 so that the denominator Q1P, Q1Q plus R1 are equal to 0. Similarly, P2P plus Q2Q plus R2 are equal to 0. Then the numerator what are getting here that is P1 dx plus Q1 dy plus R1 dx in the first case. The second case P2 dx plus Q2 dy plus R2 dz is equal to 0. You have to get that's how to solve and how to find out. Okay. Now those two solutions what you got that collectively if you write that is called the solution of the given equation. Okay. Now just to see some of the problems. There are already see some of the first problem already taken there. Now just to see here, this is the method of grouping. You are taken there. You see dx by y square by if you take these two, this is by I observing that how to write. You see here, if you take first and second, z get cancels. Remaining are involving dx, dy are x and y. That means that is easily simplifiable. That is not involving z. Okay. That means here z is absent if you take first and second. Now similarly, if you take first and third, if you take second and third, x, y, z terms are there. If you take here x square is there, here x is there. That means so one x remains as it is. That means this is containing other than y and z x is containing if you take 2 and 3. But here if you take first and third, y square get cancelled. So the remaining is equal to dx by z equal to dz by x. That is containing x square dx dz. That is easily solvable. That's why you are taking here first and second for the first case and second and third we are not taking because it's somewhat complicated that is involving dy dz y z x. If it is involving dy dz y z you can solve, but here is extra x is there here. X square x here cancel, you get the x remaining. That's why you're taking here 1, 2, and then 1, 3. Okay, if you take 1, 2, how much you are going to get here? Dx by y square z. The z get cancelled, getting dx by y square equal to you. If you write one side, you get it. By cross multiplying, you can write this. Now integrating, and integration will get here. Also, you know, the integration of x to the power n is x to the power n plus 1 by n plus 1. So same you are writing here for this also. And C means you can cross multiply here. You can take the LCM and you can cross multiply. Or taking a C1, C1 equal of course CC. That is one solution you are getting. Okay. Now by taking first and third, you are getting. You see here y square will cancel. Remaining is involving dx, dz, and x and z. Not there is no term containing y, that is already get cancelled. Okay. Now that is easily solvable. You see here the same you are writing here by cancelling y square and y square, and you are writing here dx by z equal to dz by x. Cross multiplying means you get x dx minus z dz equal to 0. Now on integration we are going to get here x square by 2 minus x square by 2, which is equal to c dash. C dash in a sense 2 c dash you get here is equal to c2 you are writing here. You see here also the same way x dx means you can write integration of x dx is x square by 2. Now z dz is z square by 2 because integration of x to the power n dx equal to x to the power n plus 1 by n plus 1. That is the known formula will be there. That is already you know that. Now from 1 and 2, if you take together, you can write, you can say that is a complete solution. Okay, this is the way how we have to find out the a solution for the by the method of grouping. Method of multipliers. Already we have discussed there. You have to choose P1, Q1, R1 so that the denominator get advantage. Whichever you are multiplying here, P1 into P means you have to multiply P1D. Plus sign means plus sign you have to write. Q1Q plus Q1Q, and here also Q1 dy you have to write. Here again here Q1 Q plus R1 R here R1 dz you have to write. The denominator get advantage. The remaining is you have to integrate and you have to get a solution. Here also the same way each fraction is equal to you have to take this and suitable one you have to take and you have to write the solution. Full solutions you have to write. Okay. Now we'll go for the problems. Okay. Now here you see dx by x into this is also a discussed in the previous case. You see x if you replace this is the cyclic order is there. If you replace x by y, y by z, z by x by z, you get the same. That is the denominator you see here. You get the that is the cyclic order. Now just you see each fraction is equal to here you are applying method of multipliers. Okay, you have to choose P1, Q1, R1. What is P1, Q1, R1? Here is P1 equal to 1, Q1 equal to 1, R1 equal to R. It's not given. If the noting that will be okay. Other by inspection you have to write here, but you have to identify and you have to write here. It's not possible. New one means you have to by trial and error method you have to solve. You have to find out the multipliers. Okay, if you take 1, 1, 1, what will happen here? You see dx plus 1 into dx is dx plus 1 into dy plus 1 into dz. Here also 1 you are multiplied dx, here 1 into this you write plus 1 into this, so plus 1 into. Whichever you are multiplying here, 1 into means the denominator also you have to multiply with 1. Here multiplying by 1 means here also you have to multiply with plus sign, you have to plus if you write in the numerator, denominator also you have to write the plus sign. Okay, now what about here? You will see the denominator of the simplification that is get cancelled on this, that is equal to, we are going to get 0. And on cross multiplication, you are getting here dx plus dy plus dz equal to 0. On integration, you are getting x plus y plus z equal to c1. Now, this is one set of multipliers are over. Okay, what are they? 1, 1, 1. Q1 equal to 1, Q1 equal to 1, R1 equal to 1. They are the set of one set of multipliers. Now, to get the second set of multipliers, this is also by inspection. You see, if you take 1 by x, 1 by y, 1 by z, how much you are going to get here? You see, if you the denominator get values, you see here 1 by x means 1 by x into dx. You are getting here 1 by x into dx. 1 by x into the same the denominator means the x get cancelled. Get here 1 into y minus z that is equal to y minus z. Similarly, here plus sign 1 by y dy. 1 by y the denominator y get cancelled. Z minus x you are getting here. The same you are getting here. Now on simplification you are getting the denominator is 0. Now on integration you are writing here 1 by x dx plus 1 by y divided plus 1 by z dz equal to 0. Now on integration you are getting here log x plus log y plus log z equal to log c. Because you see here you got the left hand side that is equal to all the logarithmic values. That's why here also you write log c2 and log m plus log n you can write as log mn, and that's why you're writing here x y z equal to c2. Hence the solution of the given equation is you are writing the two equations. What you got here, number one you got here x plus y plus z equal to c1, that is 1, and equation number 2 x y z equal to c2. There is two taken together to the complete solution. Now to see in solving the equation 1, Sometime that is in solving whatever the equation, that is the simultaneous equation. Sometimes we use both the methods mentioned above are to get the two independent solution of the given equation. That means you can use only in the method. There is no need to use the same method. That is, if you allow, it is possible to find the values by group method of grouping. You can use method of grouping, or you set of multipliers with set of multipliers. Or if you want to solve this, you can use both the methods in solving one problem. Okay, there is no need to use the both the that is the same method, but here you can use those two methods for two solutions you can use here. Okay, either of them you can use, or you can use both of them to solve this equation, solve this simultaneous equation. Okay, now we'll see the next one. Okay, now solve dx by dy by the standard format. You have to identify what is the standard format here. The standard format is dx by p equal to dy by q equal to dz by r. You see here dx by p dy by q dz by r. Now considering the second and third fractions. Second and third fractions we are taking here. Now, if you take second and third, 2x squares will cancel. Remaining are involving y z dy dz. That is easily integrable. Here, mistake is there. Dy by y is dy by y. Now you got log y equal to log z plus log c1. You are getting here. Again, log m plus log n you can write as log mn, and also you are writing y is equal to c1z. Now, the next one. Okay, here what is the method you are adopted here? Means you see here method of here one 2x get cancelled here. That means you are using the method of grouping. Is it not? Here 2x get cancelled here, and we are getting the remaining y z dy dz. That's why this is the method of grouping, that is method of grouping we are using here. Now you use the second one here. For to get the second solution, you are applying the set of multipliers method here. You write each fraction is equal to you multiply the numerator with x, and then the same with the denominator plus y dy plus z dy. It's not dx, this is dz. Okay, this is z dz we have to write here. And the same what are multiplied here, x you are multiplied with here also you have to multiply the denominator with x. Plus sign plus y dy means you have to multiply plus y into 2xy plus z dz into z 2xz into z you have to write. Okay. Now after simplification, each bracket is equal to you are going to get this x into you are getting on simplification you are getting this. Now after simplification you take any one suitable fraction. You can take dz by 2xz, or you can take the dy by 2x. I think here dy by 2xy is also there. You can take either of them. There is no problem here. Here they are preferred they are taken here dz by 2x. You can take dy dx by 2xy also you can take here. Okay. Now x dx plus y dy plus z dz by x square plus y square plus z square equal to dz by 2z. That means here you see here x is there, 2z by dz by 2xz. This x will cancel, and the remaining thing you are adding here. Now after adding that, here you see you have to integrate. You have the differential. If you take x square y square plus z square equal to t, the numerator will become dt. Okay, on integration, on differentiation, or differentiation. Now you see log x square plus y square plus z square equal to log z plus log c2 you are getting here. Log z plus c2. Because you see, if you take this x square plus y square plus z square equal to t, the denominator is dt. dt by t integration is log t. And log t means t you have to replace log x square y square plus z square you are getting here, which is equal to 1 by z dz means you can write log z plus log c2. Now again the same way here you see you can write log is there, here also log is there. That's what the constant also are writing log on either side is there. That's why writing log c2 here. Okay. Now log m plus log n you can write as log mn, but you are writing as that c2. And here removing log on either side means you can get this. So this is the way how to find out. We see in the first case we are applied the method of grouping, that is the cancel twigs on both sides. Now in the second case we are applied the set of multipliers. That is the way, that is the thing you are using here. That is in case of solving the simultaneous equation, either you can use the method of grouping, or the second method, set of multipliers, or you can use both of them. Here you are using the first one as the method of grouping, second one as the set of multipliers. Okay. Now here you see the next problem. Solve dx by here equal to dy by equal to dz. It's not dx, it's dz by. Now two sets of multipliers. Okay, here you also choosing using the here you are taking 1 minus 1 0 x y 0 you are taking as two set of multipliers. Before going to solve the equation, first you write 1 minus 1 0 is one set, x y 0 is another set. How you have to write means you see first one 1 minus 1 0 is there 1 into dx minus 1 into dy plus 0 into dz. That means dx minus dy you are getting here. Similarly, dx minus dy was 1 into 1 into the we are multiplying numerator by 1. Denominator also to multiply by 1. And denominator here you are multiplying by minus 1, dy by minus 1. And here also you have to multiply with minus 1. Okay, that means dx minus dy divided with. Okay, after simplification you are getting here dx minus dy by z into x plus y. Okay, now one more the each fraction is equal to here is that is same each fraction equal to 1 minus 1 0 if you take a set of multipliers to get the second and this compound we are going to get. Now another set is there x y 0 you are taking here. Okay, this is trial and error method and how to there is no specific method here. You see as you are taking in the case of total differential equation there you are using the working rule, but here you see you have to go for trial and error method. Here the set is second set of multipliers is x y 0. Here x y 0 means this is how to multiply with x into dx plus y into dy plus 0 into dz. Here x into the denominator plus y into the denominator plus 0 into denominator. Okay. Now after simplification here you are getting here dz by here you are getting here the first one digit by the each fraction is equal. You can take any one of the fraction out of those three. These three are the given one. You can take each fraction as you can take any of the any of these three you can take here. Now here you are choosing dz by z into x plus y because you see if you take this these two get cancels and remaining is easily integrable. Okay, is it not? Z into x plus y is there here. Z into x plus y is there. You can cancel those two and you can write the remaining thing y get cancels you are getting here dz equal to dx plus dy integrating you are getting this. Now which method you are using means here you are using the method of grouping you are using here and the first case you are using here set of multipliers then you are using the set of that is method of grouping. Now here you take dz by z into x plus y equal to x dx plus y dy. You see here you got plus sign is there. This is the mistake. This is the print mistake here. This is how to remove. So that is plus xy you have to remove and you have to write there. Okay. This is by simplification you do in paper so that you can get that. Okay. Now x plus y into x square plus y square are getting here. Again here also you see here this x plus y, this x plus y get cancels. Now what is the remaining? The remaining is dz by z equal to x dx plus y dy by x square plus y square are getting. On integration dz by z will become log z and 1 by 2 here you can take x square y square as t and if you simplify you get 1 by 2 log x square plus y square plus log c. Here you see log is there, here also log is there. That's why I'm writing here. The integral constant is also with the log sign. That is logarithm sign. Now 2 log there, cross multiply with 2 and you write here 2 log c means there is some constant you are writing here. That's 2 log c means log c square you can write log c square and log m plus log n you can write as c y square c square into x square plus y square. That c square you are writing as c2 here. Now 2 log z you can write as log z square because m log a you can write as log a to the power m. Now z square equal to c2 into x square plus y square as the complete solution is. That's what complete solution is. Now you got here what is the solution here? Z equal to x minus y plus c1. This is first one and that square equal to you have that together come to the complete solution. Okay, you got two solutions. That is enough. Here you have to identify here you are writing one set is 1 minus 1 0 x y 0 is the another set. After writing that here this is the main one here you are taking. Okay, here of course plus x you have to remove and here you are taking first fraction is equal to you are taking the second one and denominator get cancel you are getting the solution. And now the second method what you are taken that is equal to you are written here. First one is equal to the third one you are taking and you are simplifying and you are getting the solution. Okay, that is the case. Here the second method is also here the second method is also method since you are using my integration. Okay. First and last is those. Here also x plus y get cancelled here. This is method of grouping or applying here. Now the next one, solve dx by y square plus yz plus z square equal to dy by equal to dz by equal to some. Now you see here, this is in a cyclic manner will be there. You see, replacing y by z, z by x here. Here, yeah, yz means you are writing zx, zx means xy you are writing. And z is there, you are replacing by x, x by y. I've already told you cyclic chord in the sense, I already you know uh, that basic vectors, basic unit vectors, I, j, k. I by I cross j equal to k, j cross k equal to I, k cross I equal to j you are adding. Similarly, here also replacing x by y by z, z by x, x plus z you are getting this. Okay, now you see here you have to choose the set of multipliers. Set of multipliers minus we are using here. You see here first you take 1 minus 1 0, 0 1 minus 1 and minus 1 0 1. Okay. That is the way in turn, just how you have to remember means you see 1 minus 1 0 first you write here you get here dx minus dy. The next one to get the next one here, just you write this one in the next one and minus 1 here and 0 here to get there. Okay, that is 0 1 minus 1. Again you write 0 here, you write 0 and 1 here you write minus 1 and become here. Okay, that is change in the cyclic manner one by one change there so that we get that cyclic manner means. Now after simplification we are going to get here, that is after taking that multipliers we are going to get here dx minus dy divided with y square minus x square plus z into y minus x equal to dy minus dz by dz minus dx divided with your everything. Now, the same again you can simplify. You see y square minus x square is there, that we can write as y plus x into y minus x. Is it not? You see a square minus b square formula you can apply and you can write y plus x into y minus x. And again you can then take y minus x as common. If you take y minus x as common, what is the remaining here? The remaining is x plus y plus z. You get there. You see here the same you are written here. Okay. Now here also the same, here also the second component here. Now the second component is here also z minus y is there. You can write z square minus y square as z minus y into z plus y, because again a square minus b square formula. And here also you are writing the same way. Here you get the same. Here also you are getting the same. Okay. Now here totally you are getting dx plus dy by y minus x into x plus y plus z dy. You see in all these three components you got x plus y plus z as common in the denominator. You can remove that x plus y plus z by cancelling because it is containing in all the three fractions. Now the remaining is dx minus dy by x minus y equal to dy minus dz by y minus z equal to dz minus dx by z minus x we are getting finally. Now here you see taking the first and second but you will see here you can take any I'm already told you there are three variables, you get three pairs of the three different pairs we're going to get here. If you take first and second or second and third or third and first, whatever may be the way, you can get the solution because here they are easily integrable. Okay, you see the denominator x minus y equal to if you take some t, you know, the denominator will become dt. dt by t that is equal to you can write log t, you can write here also you can write the same. Here also you can write the same. You take any two fractions out of those three, you take any two fractions. First one, second, I'm taking here, and here you see dx minus dy by dy minus dz by are getting here, and integration log x minus y equal to log y minus z plus log c1. Why are writing log c1 means you see remaining are involving log, here also you write here log c1. Now again log m plus log n you can write as log mn, and here you can write x minus y equal to c1 into y minus z by removing the logarithmic sign. Okay, taking first and second fraction. First and second is already over. First and second is already over. You take another set. Here you are taking here d second and third you are taking here dy minus dz by y minus z, dz minus dx by z minus x. Now, if you simplify here, if you take y minus z equal to t, if you take the denominator will become dy minus dz that equal to dt. dt by t is again log t. The same pattern what are taking the previous case we are getting here. And we are adding here y minus z, that is log y minus z equal to log z minus h plus log c2, that you can write as y minus z equal to c2 into z minus x by taking log m plus log n equal to log mn. Now the complete solution is there are the two solutions you got there. I think you can get one more, but two is enough. If you find two solutions, two two solutions from two fractions, you got the digital field, then the digital field is solution. Okay, that is the way. Now, after this, we are discussing the simultaneous equations. Okay. Now, if you want, first we are discussing the total differential equation in the first case. Now, after that, we are taking the simultaneous equation, simultaneous equations. These are the cases. Okay. Now, here just to see the case of total differential equation, the standard form is PD plus Qdy plus RdZ equal to 0. There you got a condition of integrability. If it is satisfied, then you are taking one of the variables as a constant. Then you are going to get, if that is a constant, means f of z, you are going to get the integral constant. That you have to find out. That you have to find out. After finding f of z, after finding f of z, how you have to find out? You have to differentiate totally with respect to x plus z, and you have to compare with the given equation so that you get the involving f of z and z. After getting f of z and z containing equation, you have to solve by linear method or whatever may be the variable separable method, which method is suitable that you have to apply. And there is no specific method here, but which method which you are going to get based on that you have to solve the equation, and they will get, you have to replace f of z by that solution, that is u of x by z equal to what are getting, that u of x y equal to f of z, that is how to replace. That is a given solution. F of z value you have to find out. That is the case of total differential equation. Okay. And then one more, you have taken method of grouping. Method of grouping, that is getting us exact differential. Here you got simultaneous equations. What is the simultaneous equations? Means the standard method is dx by p dy by q dz by r. After getting that, there are two methods are there. One is the method of inspection, and the second one is the second method of cancellation, that is method of grouping, and second one is set of multipliers. Method of grouping means here you see some of the variables get cancelled or they are absent, then you can get the solution from totally you got three, means you get three components you are getting here, you get the totally three three pairs of equations. So that is one and two, two and three, one and three. Those three you are getting. After getting that, here you have to so take any two fractions. So two sets we have to take. Then that we have to solve by using method of grouping or set of one. Method of grouping means the term may be cancelled or it is option. Then you can solve the remaining thing and you can get the one solution. Again, you take another set and you find the same method is there. You have to adopt the same method. Otherwise, you did not possible go for a set of multipliers. Method of grouping is applicable. You have to solve that. Now, set of multipliers means you have to find the values P1, Q1, R1 in such a way that P1P, Q1Q, R1 are equal to P1P, Q1Q, R1 are equal to 0. That is the denominator will get 0 and remaining thing is easily integrable. What we are multiplying the denominator P1P, Q1Q, R1 R, P1, Q1, R1, or same you have to multiply the denominator also. That is P1 dx, Q1 dy plus R1 dx, that we are going to get. Similarly, you have to find out another set of multipliers, and then you have to solve and you have to get the two solutions out of three pairs. We have to find two solutions. And you see, in some of the cases, we are using only method of grouping, and other cases we are using only set of multipliers. It is not compulsory for all these cases. We have to use both also you can use for solving the simultaneous equations. There is no specific restriction, whichever is convenient that we can use and we can find out the solution. Okay. Now, up to this, we have studied total differential equations and then simultaneous equations.